Hello and welcome, and in this video we're going to continue solving exponential equations. Now in the previous video, which if you haven't watched, make sure you go do that, we used the one-to-one property, right? That was when we were able to rewrite each side with the same base. But what if we can't do that? For example, what if I had this? I can't rewrite each side with the same base. The left side has a base of 2. I can't rewrite 7 as like 2 to the 3rd or 2 to the 4th or anything like that. So I can't really rewrite each side with the same base. So what do? Well, we use logarithms, and that is the second method. So how do you solve an exponential equation with a logarithm? I'm glad you asked. This is what we do. The first thing that you need to do is you need to make sure that you isolate the exponential expression. Get it by itself. That's always going to be step one. Now, in this problem, we actually already had that, so we can move on to our second step, which is you are going to take the common log or natural log of each side. Remember, as long as you do the same thing to both sides, you can really do whatever you want to an equation. If I wanted to, I could just add 3 to each side, just because. Why not? Who cares? Well, actually, I care, because that wouldn't help us solve it. But we can go ahead and take the common log or natural log of each side. So I'm going to go ahead and take the common log of each side. So now this becomes log of 2 to the x plus 1 power is equal to log of 7. And from there, we use the properties of logarithms. In particular, here, we would use the power property. I have an exponent on our argument, which means I can actually move it out in front of the logarithm. And that's actually exactly what I would do. I would move the x plus 1 out in front of that log 2. Because now I can just divide each side by log of 2. That log of 2 is multiplying the quantity of x plus 1. And now what we do is we now just solve for x. So, well, or whatever variable you're talking about. So I could go ahead and divide each side by log of 2 to get x plus 1 is equal to log of 7 divided by log of 2. Then all I have to do after that is subtract 1 from each side. So I'd get log of 7 divided log of 2. Plug that into your calculator. It's going to get you some pretty nasty decimal. Then subtract 1 and boom, you got it. I'm going to go ahead and round this a little bit because it's going to be necessary to round pretty much every single one of these. And I got roughly 1.807. Now that is how you solve an exponential equation using logarithms. However, there's one slightly different way that we could use logarithms to solve this. And it actually has to do with the second step. There is kind of an alternative to that second step, and this is actually kind of how I like to do it a little bit more. What it involves, instead of taking the common log or natural log of each side, you rewrite the entire equation in logarithmic form. And how would we do that? Well, let's go ahead and see. If I have the exponential equation 2 to the x plus 1 power is equal to 7, that is the same as log base 2 of 7 is equal to x plus 1. Remember, we focus on being able to rewrite from logarithmic to exponential form and vice versa so much. And it's because it comes in very, very handy here. And I actually prefer doing it this way, so you're probably going to be seeing me do it this way. But now step 3 says use properties of logs. Well, I don't see an exponent anywhere. How do I plug log base 2 of 7 into my calculator? What is log base 2 of 7? Well, it's some pretty nasty decimal. And we actually kind of already found it in the previous method, because the property that we now use is a new one that we haven't really talked about yet before, which is called the change of base property, which basically allows us to change the base of a logarithm to whatever we want. And this is the general definition. If we have some logarithm, log base b of x, that is equivalent to log of x divided by log of b, or the natural log of x divided by the natural log of b. Basically, you can actually change the base to whatever you want. I could change it to like log base 3 of x divided by log base 3 of b. However, because calculators generally only come with the common log and natural log functions built in, we are going to be using those two especially. And I'm going to go ahead and use the common log. So that is actually how we got this right here. Log of 7 divided by log of 2. We use the change of base property. It's always log of our argument divided by log of our original base. So that's actually how we kind of get log of 7 divided by log of 2. Log of our argument divided by the log of our original base. And that would be equal to x plus 1. And now notice the next step, all I'd have to do is subtract 1, and that's exactly what I got. Notice I get x is equal to log 7 divided by log 2 minus 1. Log 7 divided by log 2 minus 1. I get the exact same final step, and that is always going to happen. So that is how you solve exponential equations with logarithms. Now I want to go ahead and run through a few extra examples with you guys. We're going to get rid of all the steps. Make sure you have those written down. I am probably going to be using the alternative way just because I think it's a little bit easier. If you prefer the first way, feel free to do it that way. It's math. There's generally a few different ways to get the final answer, as long as you get the final answer. So let's go ahead and take a look at another example. Okay, let's take a look at this example here. We have 4 times 15 to the x minus 2 power is equal to 40. Well, the first step is to always get the exponential expression isolated. In this problem, that's actually not happening yet. The exponential expression is just the base and the exponent. So it's 15 to the power of x minus 2. So that 4 out in front has got to go. And that 4 is multiplying our exponential expression, so we would have to divide each side by 4. So that would end up getting us 15 to the x minus 2 power is equal to, and if I divide each side by 4, I'm going to get that equal to 10. Okay, and now remember, I can go 2 different ways. I can take the common log or natural log of each side, or I can rewrite each side I can rewrite this in logarithmic form. I'm going to go ahead and choose the latter, okay? Because now I have my exponential expression isolated. So I'm going to have log, the base was 15, the base is going to stay 15. Log base 15 of 10 is equal to our exponent of x minus 2. And remember, if you're taking this approach, now you have to use the change of base property. So that is going to be log of our argument, so log of 10 divided by log of our original base, log of 15, is equal to x minus 2. Now, if you want to plug this into your calculator now and just kind of store that decimal, it's going to be a crazy decimal right now, feel free to. I like to plug everything in at the very end. And now what we would do is we would add 2 to each side. So I'm going to get x is equal to log of 10 divided by log of 15 plus 2. And now I can go ahead and plug this into the calculator. So I'm going to have log of 10, so log of 10 divided by log of 15. I'm going to go ahead and find out what that is first. There we go, plus 2. And this would end up being our final answer. So I'm going to make that 2.850, or just 2.85. And that would end up being our final answer. Okay, good. So that is another example. Let's go ahead and take a look at another one. This one's going to be a little bit trickier, just a little bit more work, but I promise it's still not that bad. So let's go ahead and take a look at another one. Okay, so we have 2 times 3 to the 2x minus 5 power minus 4 is equal to 11. Now our first step, remember, is to always isolate the exponential expression, which is the base and the exponent. The base is 3, the exponent is 2x minus 5. So we have to isolate that. So the first thing that we should do is we should add 4 to each side. So I'm going to go ahead and do that. So I'm going to have 2 times 3 to the 2x minus 5 power is equal to 15. There we go. Now, it's still not isolated. 2 is multiplying our exponential expression, so I need to divide each side by 2. So I'm going to have 3 to the 2x minus 5 power is equal to, you can write that as 15 halves. I'm actually going to write it as a decimal 7.5, just because I know eventually I'm going to have a fraction, right, with logarithms, have 2 logarithms dividing one another. And yes, I'm normally not the biggest one for using decimals and instead using fractions, but I'm going to go ahead and use a decimal here. Now we have the exponential expression isolated. So now we can go ahead and rewrite this in logarithmic form. The base is 3. Well, guess what? The base is staying 3. So this is going to be log base 3 of 7.5 is equal to 2x minus 5. Okay? And now I can solve for x. Oh, wait, I should probably use the change of base property first. So I'm going to go ahead and use change of base. This is going to be log of our argument, 7.5, divided by log of our original base 3. And this is going to be equal to 2x minus 5. Now I can solve for x. Log of 7.5 divided by log of 3 is just a number. Don't freak out. It's just a number. Treat it like one. If I was solving for x normally, I would add 5 to each side. Well, guess what? I am solving for x normally, so I'm still going to add 5 to each side. So this is going to end up becoming log of 7.5 divided by log of 3 plus 5 is equal to 2x. And now if I was normally solving for x, I would divide each side by 2. Well, guess what? I still am normally solving for x. So I'm going to divide each side by 2. Warning you now, this is going to look real messy. Don't worry, just type it in one step at a time. We'll be fine. So x is going to be equal to log of 7.5 divided by log of 3 plus 5. And all of that is being divided by 2. Looks pretty nasty, but we got calculators. That's what they're for. So let's go ahead and plug this into the calculator and round appropriately. Okay, so let's plug this in piece by piece. So I'm going to go ahead and do log of 7.5 divided by log of 3 divided by log of 3. There we go. I had to add 5 to that, so I'm going to add 5 to that. Then I had to divide by 2, so I'm going to divide by 2. And there we go, 3.417. Let me go ahead and write that down. 3.417. Now, in these cases, people maybe will not check their final answer just because they may not want to have to type all that in by hand. But you can go ahead and always store your answer and see if it works. Okay, so I'm actually going to show you guys real quick. It's just a neat little calculator thing you can do. If I hit this STO and then an arrow button, I can actually store this. I can store this as any variable I want. I'm going to go ahead and use x. Now x is that. And now I can literally just type in. I can literally just type in the left side of the equation and see if it makes it equal to the right side of the equation. So that's what I'm going to do. 2 times 3 to the 2x minus 5. And I know I'm typing in x here. It's because I stored it as that actual number. And then minus 4. And that got me 11. And look, the right side is 11. That means it works. So you can always do this and double check your answer. And you can use that same idea to check your answer for like solving any type of equation. Okay? Because sometimes the answer might be a little bit messy, but you want to check your answer. Let's go ahead and take a look at one, yes, I promise, one final example. Okay, so our fourth example, we have e to the 2x power plus 5 is equal to 16. Well, once again, remember we have to isolate the exponential expression. That is step one. I'm going to repeat it again. And remember, that's just a base in the exponent. Our base is e, and our exponent is 2x. So that's what we've got to isolate. So all I have to do that is subtract 5 from each side. So I'm going to get e to the 2x power is equal to 11. Now that we have this isolated, we can go ahead and rewrite it in logarithmic form. Well, the base is e. Well, the base is going to stay e. So that'll be log base e of 11 is equal to 2x. And some of you might be wondering, wait, isn't that a special logarithm? Don't I have that in the calculator? Oh, yeah, you do. Log base e, remember, is the natural log. So I probably wouldn't even write it that way. You could. It still works. You can still use the change of base property with that. Just know that. But you actually already have that in your calculator. Log base e is the natural log. So that'd actually be the natural log of 11. Uh-oh, those look way too similar. Just know that's an ln, and then the number 11, is equal to 2x. And then from there, all we have to do is divide each side by 2 to solve for x. So x is going to be the natural log of 11. I'll put 11 in parentheses. I don't know if that made it any better. Divided by 2. And we can go ahead and plug it into the calculator just like this. Natural log of 11. Boom, that's what we get, divided by 2. There we go, 1.19, and then that would actually round up to 9. Okay, so 1.199. That would end up being our final answer. And remember, you can always store this and double check e to the 2x, so I can go ahead and do that. e to the 2x. Notice I have one of the older calculators here. If you have one of the newer ones, it's probably a lot easier. Use the fraction button, use the pot. When you type in an exponent, it's just like a nice little block. You can type it right in. The older ones, make sure you use parentheses correctly. So e to the 2x power, and it was plus 5, and this should get me 16, and oh, look at that, it does. It's because it's right. So our answer would be 1.199 roughly. And that is it, and that is solving exponential equations. Now, there are some more challenging types of exponential equations. I may make a video of them. Just know that these next couple of videos based on exponential equations would be higher level ones, probably geared a little bit towards more towards pre-calculus as opposed to just like algebra 1 and algebra 2. Okay, so don't feel bad if it's just like maybe a little bit too tricky. Practice with this stuff first. These are the two big main types, using the one-to-one property and using logarithms. Make sure we are 100% solid with this before we move on to more complex exponential equations. But before we even get to those, we got to talk about solving logarithmic equations. And that's what we'll be doing in the next couple of videos. But I hope this one was helpful. If you have any questions, make sure you reach out and let me know. And look forward to seeing you guys in the next video.